Welcome students to this particular session of preparation of X bar chart by second method. In previous video, we have seen the preparation of X bar chart where the standard deviation value has been given to you or has been available to us. Now, in some cases, if the standard deviation values of the process is not known to us, in that kind of case where the standard deviation value is not available with us, then also we can plot the X bar chart by using the following method. When the standard deviation value is not given for the particular process, then we use the sample range as a measure of the process variability. So to decide the UCL and LCL, we will be following these two equations. When the standard deviation value is not available with us. Now the UCL can be found out by using the equation UCL is equal to X double bar plus A2 R bar. And LCL can be found out by using this equation X bar minus A2 into R bar. Now, what is R bar? That we already have discussed. That is the mean, that is the average of the ranges of all the samples. And A2 is nothing but a factor. The value of this particular factor will be selected from a particular table that is shown on this particular slide. Now, if you will see this particular table over here on the first column, the number of observations or number of items has been given to you. Number of readings have been given to you in each sample. So this first column is just showing us the value of small n. And in the second column, we are able to find out the factor of X bar chart A2 value for a particular number of items or particular quantity of each sample. So if your sample size is equal to 2, then the value of A2 will be 1.88. If the number of items or the sample size is 9, then the value of A2 will be 0.34. Suppose your n value is 17. At that time, the A2 value will be 0.20. So from this table, we can identify the value of A2 factor. And then after, we can plot or we can put A2 value over here. We are already aware with the process how to find out the X double bar and R bar. So after plotting or after putting all these values, we will have the values of UCL and LCL. Now just to understand the process, let us consider a particular example where the same data which we discussed earlier has been taken over here. Only the difference is that in previous example, we had a particular value of standard deviation. We were given that value. The value of sigma was given to us. Now in this case, what change has been made? All the data is similar. Same data is there. Only the value of standard deviation is unknown. It is not given to us. OK. Otherwise, the sample size is same. Number of samples are same and all the values are also same. OK. So if we go through this particular particular example, then we are having 5 samples. We already are aware with the different values of X bar. How to find out the X bar, that we are aware with it. Now, after finding out this X bar values, we will be finding out the X double bar values, and X double bar is equal to 12.11 that we found out. Now we are aware with the quantity or the number of n, number of small n, that is the number of quantity or the sample size. over here, the sample size is 4 or the value of small n is 4. So from this particular table, we are able to see for if the value of n is 4, then the value of A2 will be taken as 0.73. Okay, so over here from that table, for n is equal to 4, the A2 value that we found out, that is equal to 0.73. Okay, now the equation of UCL is x double bar plus A2 R bar. So x double bar has been found out over here, that is equal to 12.11. The value of A2 that also has been found out from the table, that is equal to 0.73, and R bar, that is nothing but the average of all the ranges of all the samples. So R bar, to find out the R bar, we need to find out the ranges for each sample. So let us find out the range for the sample 1. How to find out the range for a particular sample? In one sample, number of values will be there, number of items will be there. Now, out of all these values, the maximum value which will be picked up and smallest or the minimum value will be picked up, and we will be taking the difference of them. So over here in sample 1, if you see, the 12.11 is the highest value and 12.08 is the lowest value. So the difference between 12.11 and 12.08 will be taken as the range 1. It means that range for sample 1. So it is equal to 0.03, which has been taken over here. Now for sample 2, the maximum value is 12.15, minimum is 12.10. So the difference between these two, maximum value and minimum value, that is 0.05, which has been taken over here. Same way in sample 3, maximum is 12.15, minimum is 12.09. So the difference is 0.06. The range is 0.06. Now for sample 4, the maximum value is 12.12, minimum is 12.08. So if you will take the difference of them, you will be able to find out the range for sample 4, that is 0.04. And for sample 5, the range will be equal to 0.05. So the summation of all these ranges R1 to R5 will be done, and it will be divided with small k. Small k is nothing but the number of samples. So here 5 samples are there, so it will be divided with 5. So range that we will be finding out, R bar that we will be finding out, that is 0.046. Now we are having the value of x double bar, A2 and R bar. So we will be putting all these values in between these two equations, UCL and LCL is equal to x double bar plus or minus A2 bar R bar. So when we'll be putting all these values, the UCL will be equal to 12.14, while the LCL will be equal to 12.08. Okay, so now after having the UCL and LCL and X bar values, we will be plotting a X bar chart where as the mean line will be drawn with reference to the value of X double bar. So this X double bar 12.11 shows us the mean line. Then UCL, that is 12.14, it will be above the mean line, above the X double bar line. Okay, and below the mean line or below the X double bar line, LCL will be plotted. So 12.08 will be LCL, 12.11 will be the X double bar, and 12.14 will be the UCL. So after plotting mean line or the X double bar line, LCL and UCL, now we are going to plot the values of X bar 1, X bar 2, X bar 3, X bar 4 and X bar 5 on that particular chart. And we will be finding out whether all these points remained in between LCL and UCL or not. On the basis of those plotting, if any of the point is crossing either UCL or the LCL, then we can conclude that the process is not under control. But over here, in this particular case, all the values of X bar 1, x bar 2, x bar 3, x bar 4, and x bar 5, all these values lies between LCL and UCL. That is 12.02 and 12.14. So all these values on the given in the last row are falling between 12.08 and 12.14. So it means that we can say that this particular process is under control. Okay. So likewise, you can solve any example, or you can prepare X bar chart by using the following methodology, following equations. When the value of standard deviation is not given to you, when the standard deviation value is not given to you, you will require to have the you need to take the support of this particular table. From this table, as per the sample size, or the as per the value of number, as per the value of small n, you will be able to find out, or the pick the value of the A2 factor from this particular graph, or sorry, particular table, and then you can plot it in the equation, and then after you just plot the X bar chart and then decide whether the process is under control or not. Thank you.